code for fun. So here is the problem. We are given a directed acyclic graph with n nodes and m directed edges. Print the list of ancestors nodes in increasing order. So I will try to explain it with the drawing. So there are 5 edges first. So and there are 5 nodes and 4 edges. 0, 1. It is zero indexed graph. 3 and 4. So for this, the parent or ancestor for 0, there are no parent or ancestors for 0. There are no parent or ancestors for 1. But for 2, we have two parents, 0 and 1. For 3, we have a direct edge from 2 to 3. So the direct parent is 2. And for 2, the ancestors are 0 and 1. For 4 also, we have the same thing. So the answer should be like for 0, it should be an empty list or vector. For 1, it should be empty list or vector as there are no parent or ancestors. For 2, it should contain 0 and 1 as both are direct parents. For 3, the direct parent is 2, and for 2, the ancestors are 0 and 1. For 4 also same case, 0, 1, 2. So yeah, this is what we need to find. So I will try to extend this example. If there are more than one components, like this is a one component, this is a single component. So if you have more than one component, like along with this we have 6, 5 and 6, consider 5 and 6. So for this, the 5, as 5 doesn't have any parent, it should contain an empty vector or list, and 6 should contain only 5 in the answer list. So yeah, this is the problem. As you can see, the example is what I gave. From that, there's a direct edge from 0 to 2, 1 to 2, 2 to 3, and 2 to 4. So the answer should be in this format, vector of vector or vector of list. You need to just print, so it doesn't matter in what format you have. 0, 1, 2, 3, 4, and what are its ancestors. So let's start with the code. As we can see, they asked the parents or ancestors. The first idea which comes to my mind is the topo sort. So for topo sort, let me say what is topo sort first. In topological sort, if there is a node edge from U to V, then in the sorting order, U should come before V. So in this case, there is a direct edge from 5 to 0, 5 to 2, 4 to 0, 4 to 1, 2 to 3, and 3 to 1. So let's try to remove the nodes in order to make it free. So for 0, this 5 is kind of a prerequisite when we do a traversal, and 4 is also kind of a prerequisite. So first we should have 5 or 4, then we should have, then 0 will be empty. It doesn't matter, we can have 0 anywhere. So here 2 is also empty. As 2 also, if you remove 5, 2 also won't have any direct edge from a parent or something. So we can remove 2, 3, 1, 0 can come after 4 also, after 2 also, after 3 also, it doesn't matter. So to solve topological sort, there is a common algorithm known as Kahn's algorithm. This is kind of finding the in degree of each node and do a BFS kind of a traversal. So in degree of each node means what are the number of edges coming directly from a parent to the node. So here we can see there is no parent for 5. So in degree will be 0. For 0, there are two parents, 5 and 4. So in degree will be 2. So for 2, the in degree is 1. For 3, in degree is 1. For 1, in degree is 3. So to do the topo sort, we should first put the nodes with in degree as 0 in the queue, and we should further move on. As you can see, so I have coded in C++. Soon I will give the link for Python code in my description. You can see and understand it. So first pause the video and try to think by yourself. Then I will start explaining the code. First, I'm trying to get n and m. N is the number of nodes. M is the number of edges. So I'm trying to store the edges in a vector of pair of edges. So I will get to the edges here. As I have already got the M and M, I have already predefined the size of edges and adjacency list. I have also took the vector of int of in degree, that is to find to store the in degree of each node. So here we can say I got an directed edge from 0 to 2. So I'm going to push in the adjacency matrix, I'm going to push at zeroth position 2, and in degree of 2 will be increasing by 1 as there is a directed edge from 0 to 2. So I'm going to store the answer in vector of set of answer. So in Kahn's algorithm, as we already mentioned, it is a BFS kind of traversal. So we have took the queue, and I'm going to put all the nodes with in degree 0 inside the queue. So I would say this is kind of a level order traversal, that is to traverse for the size of the queue which is present. So while not of queue dot empty, I'm first getting the size of the queue. Next, I'm going to traverse for the size of the queue. First, I took the top node, that is friend node in the queue, and I'm popping it out and I'm storing it as a node. In our case, I would have put 0 and 1 in the queue. So in our case, the top node is 1. So I'm removing 1 from the queue as I already popped it. So I'm going to uh, insert 1 for the nodes which have a directed edge from 1. That is in our case 2 as a directed edge from 1. So I'm going to, as the answer contain, you can clearly say answer contains 0 and 1. I'm going to insert the direct parent of the neighbor node. I'm going to insert the direct parent of the neighbor node. Our neighbor node is 2 here. So I have mentioned this it is the neighbor node in our case. So answer of neighbor node will contain the node from which it came, that is 1, and I'm also going to store all the ancestors of 1 in this case. As in 3, there will be the neighbor node. When we check for 2, the neighbor node will be 3. So I will be first inserting 2. After that, if I check for 2, the ancestors are 0 and 1. So I'm inserting 0 and 1 in this case. So for x of answer of node is 1 in our case. So for all elements in the node, I'm trying to insert it in the neighbors node also. And I'm decreasing the in degree of the neighbor node by 1. So as I already removed this one, as I already removed that one from the queue, so as I already removed this one from the queue, so I'm decreasing the in degree of 2 by 1. So whenever the in degree becomes 0, I'll push that node inside the queue. So in this case, when I pop, as I already checked one, so it is gone. So next to the front element is 2. Front element is 0. So for 0 also I will check its neighbors are 2. So I will decrease the in degree of 2 by another one. So in degree of 2 will also become 0. So I will remove 0 also, as 0 is already popped. So for now, the in degree of 2 will become 0. So I will push that inside the queue. Push that inside the queue. Sorry, guys. I'll push that inside the queue as 0 is also removed. Next, who are the neighbors for 3 and 4? So first I will go and check 3. So in degree of 3 will reduce by 1. So already the in degree of 3 was 1. So when I reduce the in degree of 3 by 1, it will become 0. So I'll later I'm checking for 2. So I'll pop the 2. Then I will push 1 as in degree of 3 is 1. So again, uh, 2's neighbor are 3 and 4. I have already checked the 3. Now I'm going to check for 4. So for 4, as we can see, 2 is the parent. So in degree of 4 will become, will in degree of 4 will reduce by 1. So the in degree of 4 will also become 0. So I will also I will also push 4 inside the queue. Again, I will go check for neighbors for 3 and 4. As there are no neighbors, I will directly push that inside it. So as I already told, for each node while I'm checking, first I will push the parent node of the node. That is, for the neighbor's node, the parent node is node. Next, I will push the ancestors of the parent node. In our case, as I already told, uh, for three, the straightaway parent node is two. For three, the straightaway parent node is two, but two will already have zero and one as their parent or ancestors. So I will push first three, two in our case. Next, I will traverse through this zero and one. Then I will push all the elements inside the uh, set, I would say. As it is vector of set, so duplicates doesn't matter, duplicates won't be considered, and it will also be in an increasing order. So at last I'm uh, printing the parent node and what are its ancestors or node and what are its parent or ancestors nodes. So in our case, 0 contain no parent, 1 contain no parent, 2 contains 0 as 1 is parent, 3 is direct parent is 2, 3's direct parent is 2, and two's ancestor or parent is 0 and 1, as I already have it. So yeah, this is the case. So let's see for other case when there are more than one component. So consider the number of nodes. I am increasing the number of nodes by 2 and just increasing it by 1 edge, and I am just placing the direct edge from 5 to 6. So I will try to run the loop. As you can see, 5. So it is similar case to our first case only. So 0 is 1, 2, direct, 3, 4. Then there is separate component 5 and 6. These both are completely unrelated. So as you can see, there are no parent or ancestors for 5. It should be empty. So 5 should have empty. And 6 direct parent or ancestor is 5. So 6 should contain 5. So as you can see, the answer for 5 is empty and 6 is 5. So this is the question asked in Amazon interview. So further, I will come up with many other interview questions and lead code questions, code forces questions. So do subscribe and wait for further questions.